Here today we're covering section 3.3, linear equations in two variables. So we're going to recognize linear equation in two variables, find intercepts of coordinate axes, graph horizontal and vertical lines. Recognizing a linear equation. A linear equation is an equation that can be written in the form of ax plus by equals c. This form of the equation of a line is said to be in standard form. The graph of a linear equation is a straight line. So when they say in standard form, usually you have the x first, then the y, with plus between them, set equal, there's a constant. Now you could be missing an x or a y in itself. Its coefficient would be 0. We'll talk more about that in a second. Notice the leading coefficient in front of the x is 1 in this case. Alright, so are the following equations linear? So let's put them in standard form to see if they are. So to put this in standard form, I'm going to move the x to the left-hand side. So I'm going to rewrite this as x, and that's going to make it a negative x. And then I'm going to have plus, and then instead of writing this as y over 2, I'm going to write this as 1/2 times y equals negative 3. So now I have my coefficient in front of x is negative 1. X is by itself. My coefficient in front of y is 1/2. Y is by itself, equal to a constant. And that constant could be 0. Let's do the next. This one's very similar. Starts out similar. So I move the x to the left-hand side. I get negative x. Oh, let me say the equation outside. So for part B, it's 2 over y equals x minus 3. So I'm going to move the x to the left-hand side, and it'll become negative x. And then I'll move the 2 out front of the y, and I'll have plus 2 times, and this is going to be 1 over y. And that's going to be equal to negative 3. Now, if I wanted to get this y out of the denominator, I'd have to multiply everything by y, and then I'd have x times y, which isn't allowed. But another way you could look at this is be rewritten as negative x plus 2, and this is y to the negative first power. And here, that's not a linear term, right? Because y is not to the first power; it's to the negative first power. So that's another. So this one is no, and I forgot to write yes up here for the first one. This next one right here, we've got our x and y on the same side. That's fine. That's how we want it. But the x is actually we write it in rational power to the 1/2 plus y equals 5. Well, x to the 1/2, it's no longer the first power. That's what gives us our trouble. Let me circle our problems here. That gives us a problem. It's no longer linear. So this would be a no. So next are the following equations are linear. So now we have a problem D, which is the square root of 5, then times x. That square root doesn't extend over the x. Minus y equals 19. So here, it's already in standard form. We have our coefficient right here times our x. We have negative 1 times y equals 19. The x and the y are separate. So this, yes, is linear. Next we have E, which is x times y plus 3y equals 2. So in this case, I have my x times my y here. So in order to separate this x from the y, what you normally do is you divide everything by y. But if we did that, let's say we divided both sides by y, we'd end up in the same place, or multiplied by y over 1. We get that x plus 3 equals, well, 2 over y. We're in that same case where we have y in the denominator again, or y to the negative first power. I can't have my x's and my y's multiplied together. And even if I tried to correct that by dividing everything by y, it still wouldn't give me a linear equation, because I get that y stuck in the denominator. So this y right here is our problem. It's our x times our y. We already have a y term. This is x times y. That gives us trouble. And the answer is no for E. Next, we talk about x and y intercepts. The x-intercept of a line is the point blank 0, where the line that intersects the x-axis. In other words, the y-coordinate of the x-axis, the y-coordinate of the x-intercept is always 0. And we can see this if we draw a quick, x and y axis here, this being our x-axis. If I want to be on this line, well, then my y coordinate has to be 0, right? So if I want to be here at A, y has to be 0. And then the y-intercept of a line is the point 0 blank, where the line that intersects the y-axis. In other words, the x-coordinate of the y-intercept is always 0. Once again, we draw an xy axis and we say, hey, if we want to be on the y-axis right here, well, our x-coordinate has to be 0. I'm going to move 0 left, 0 right, and then move up y units. Alright, so here it says find the x and y intercepts of the equation of the graph, if they exist, and then graph the equation. The x and y intercepts of the equation, if they exist, and then graph the equation. So they give us this right here, and they say it's already in standard form. We got 4x plus 3y equals 24. So what we can do real quick is to find, find x-intercept. So if I want to be on the x-intercept, then let y equals 0. So I'm going to say 4x plus 3 times 0 equals 24. So 4x was 24. So that gives me x. So I divide both sides by 4. X equals, what is that, 6? Remember, this is not the coordinate. This is just the x-coordinate of my coordinate. So I have to rewrite this as 6, 0 as my x-intercept. Do the same thing for y now. Find y-intercept. So I'm looking for the y value, so I have to let x be equal to 0. So I'm going to have 4 times 0 plus 3y equals 24. So 3y equals 24. Divide both sides by 3. I get y equals, what is that, 8. And so that's going to give me the y coordinate. So I know my x coordinate had to be 0, my y had to be 8. Now, you can do it this way, but there's a little bit easier way to set this up and solve, and it's one of the advantages of having it in standard form, especially if both the coefficients of x and y are factors of factors of your constant, in this case 24. People call it the cover-up method. Every year they label it something different, so they can sell you a different textbook with the same math in it. And so basically how I tell my students to set this up is basically you write here, you say I want my x-intercept and I want my y-intercept. And if I want the x-intercept, y has to be 0, and if I want the y-intercept, the x has to be 0. Everybody with me on that? So here, if it's set up so it's x, then y, equal your constant, you can cover up the y or the y component, right? And this just says, if I plug in 0 for y to get my x-intercept, then I'm going to say 4x equals 24. So divide both sides by 4, I get x equals 6. And I cover up this side because I'm plugging in 0 for x for my y-intercept. So I'm going to get 3y equals 24. Well, I divide both sides by 3, and I get 8 for my y-intercept. And that's just the easiest way to do it. You don't have to write all this down here. This is the math you're doing, and it's simple math. It's nice math. You can get fractional x and y intercepts, but they try to give you nice problems, at least in this section, where a lot of times you'll get whole number or integer intercepts for your coordinates or integers for your coordinates, and all you have to do is this cover up method because they divide it nicely. Sometimes they don't, sometimes they do. Depends on the problem, what they're asking. Next it says find the x and y intercepts for the equation. And here they don't put it in standard form. And they give us 2 times y minus x quantity plus 1 equals 6x minus 15. If they, and they say this, oh, I was supposed to graph it. I forgot to do something on this one. You get ahead, you want to just solve all the problems. Then graph, read the instructions. That's one good thing about Hawks though, because they won't let you partially answer a question. They'll ask for it, and you'll say, hey, you left this blank. So let's graph it real quick. And if you have the x and y intercepts, they're real nice to graph. So if I want to graph this first one, I go over 6. 1, 2, 3, 4, 5, 6 right here. That's my x-intercept. My y-intercept is 1, 2, 3, 4, 5, 6, 7, 8 up here. Oops, that's not what I'm doing. I'm graphing the y-intercept. It's up here. And so now I'm going to connect these 2 points, assuming I can draw a straight line. Yeah. Don't make the mistake I just did. I see a lot of students, they'll find the x and y intercepts, and then they'll plot that like it's a point in itself. And they'll plot this over here, and they'll get a straight line or something, and they'll get a horizontal or vertical line or something. Don't do that. See a lot of students do that. You want to, one of the coordinates of your is going to be on the x or the y-axis. Well, both of the points are going to be, one's going to be on the x, one's going to be on the y, if they have them. All right, so let's go back to example 3 and find the x and y intercepts for the equation. And we have 2 times y minus x quantity plus 1 equals 6x minus 15. And if they exist, because horizontal and vertical lines, we'll cover those in a second. Then graph the equation. So we're going to graph this equation, and we're going to first put it in standard form. So I'm going to say this is 2 times y, which is 2y, minus 2x plus 1 equals 6x minus 15. I'm going to subtract 6x from both sides to get it on the left. So my x and y is on the left. And then I'm also going to subtract 1 from both sides. And that's going to give me, and I want to write my x's first so it matches the pattern. So I'm going to say negative 8x plus 2y equals, and then I'm going to have this negative 16. So now we can do the cover-up method. So I'm going to give my x-intercepts and my y-intercepts. So x-intercept, y has to be 0, y-intercept, x has to be 0. So now I'm going to cover up my y component for my x-intercept, and I'm going to get negative 8x equals negative 16. I divide both sides by negative 8. You need to write that off to the side somewhere. You're going to get positive 2 back out. And then you cover this up, and you're going to get 2y equals negative 16. And so you can, once again, go off to the side if you need to and say negative 16 divided by 2 gives me negative 8. And so that's your answer. You have negative 2, 0 for the x-intercept, and 0, negative 8 for the y-intercept. And we graph this. And so where do I want this? So that's my x-intercept, and then I'm going to go 2 over from x on the x-axis and down 8, 6, 7, 8 right here. Then I'm going to graph a line. All right. Now, somebody might have noticed and said, wait, I worked this problem, I got something a little bit different. Is it the same? And sometimes people will notice that if every coefficient is divisible by the same number, you have a greatest common factor, including your constant, you can factor that out. I could have rewritten this equation as negative 4x plus y equals, this doesn't want to write, negative 4x plus y equals negative 8. So it'll come out to be the same answer. You just divided everything by 2. These are actually the same line. These lines are equivalent. You can even make this, you can even see this line written as 4x minus y equals 8, where I multiplied everything by a negative. So all these lines are the same lines. They're multiples of each other. We'll talk more about that later in the semester when we talk about systems of equations. But you could get a different equation of a line, but end up the same. You could get a different form of the same line, just written differently. You know, it'd be a multiple of it somehow. Next, we're going to talk about horizontal and vertical lines. So every point on a horizontal line has the same y value. So a horizontal line can be written in the form of y equals b. In other words, in this case, we have y equals 2. And basically it says no matter what point is on this line, as long as its y coordinate is 2, we're good. So this could be the point 0, 2, Another point on the line could be something like 4, 2, but everything will have the same y coordinate. So since the x isn't declared, we haven't put any restrictions on the x. The x can be anything it wants. It could be 0, it could be 4, it could be negative 17,000. As long as my y coordinate's 2, I'm going to be on this horizontal line. Also, every point on a vertical line has the same x value, so a vertical line can be written in the form of x equals a. In other words, on this line right here, where all my x coordinates are 3, this could be 3, 0. This could be 3, let's just say this is 2, 3, 2, so forth and so on. Whoops, 3, 6, parentheses, and so forth and so on. And so as long as all your x coordinates are 3, you're going to be on this vertical line, x equals 3. So for find the x and y intercepts of the following equation for exercise 4, we're going to have the equation 7y plus 5x equals 5x plus 21. And if they exist, then graph the equation. So looking at this real quick, we have 7y plus 5x equals 5x plus 21. Remember, if they have the same sign in their opposite sides, you can cancel them. All right. I'll write out a long form here. So we cancel the 5x on both sides, and we get 7y equals 21. Divide both sides by 7, and I'm going to get y equals 3. So since there's no x, and this is a line, this is no x coordinate, that means it's going to be, in this case, a horizontal line. And it's y equals a number, so it's a horizontal line. So when I go to graph this, it wants the x and y intercept. Once again, it's going to have all my y coordinates. The only intercepts it's going to have is going to be where my y coordinate has to be 3. So this is 0, so that means that it's going to intersect the y axis. It's going to be y-intercept. It's not going to have an x-intercept because I'm never going to hit the x-axis unless I am the x-axis. Right here, 3. Draw a line here at 3. And so I'm never going to hit the x-axis here, so the x-intercept is going to be none. Because there's no way I can get this x number to be anything, there's no way I'm going to be able to get the y coordinate 0 because all my y coordinates have to be 3. This is 3, 3. This is 0, 3. This is negative 1, 3, so forth and so on. There's no way to make this y coordinate 0 to get me to cross the x-axis. So there'll be like an absent button or none or something for when it asks for x and y intercepts of horizontal lines. That's it for this lesson. Hope you all have a good one.